Oh, let's just be real for a second here. Usually when we start these deep dives, we do the whole, welcome back curious minds kind of routine.
Right, we ease into it.
Yeah, we talk about broad trends, we do a little gentle wading into the pool.
Hmm.
But today is, well, it's very different.
Highly different. Because today, we are answering a very specific and honestly, a somewhat aggressive call from a listener.
Aggressive is a good word for it. We're just going to call this listener the technician.
The technician has a nice ring to it. Sounds like, I don't know, a character in a spy novel or something.
It really does. But this listener actually works at CERN. They are literally currently surrounded by the Large Hadron Collider.
Which is just the most advanced particle physics machinery on the planet.
Right, and frankly, they are fed up.
Fed up might be putting it mildly.
Yeah, they sent us this message basically saying they are sick to death of the hype surrounding this, quote, lattice water bubble theory that's been making the rounds.
The water matrix, right?
Exactly. They said, and I'm quoting here, I don't want personalities. I don't want philosophy. I don't want to hear about how beautiful the universe is. I want a duel.
A duel, I love that.
A literal duel. They want us to strip away all the noise and just pit the reigning heavyweight champion of cosmology against this radical new challenger.
They want the receipts. They want us to pull the references, check the math, and see which model actually holds water.
And pun absolutely intended on that one.
Completely intended. And look, it is a very fair request, especially given where they work. I mean, in the world of high-energy physics, you can't just, wave your hands and say, hey, the universe is made of water.
That does not fly at CERN.
No, it doesn't. You need to show your work. You need falsifiable predictions. You have to explain why the current model works so incredibly well and exactly where it supposedly fails.
So that is our mission today. We are stepping right into the ring. We are putting on the referee shirts. So let's introduce the contenders.
Okay, let's do it.
In the blue corner, we have the incumbent, the standard model of cosmology, otherwise known as Lambda-CDM.
The absolute heavyweight champion.
The heavyweight champion, represented today by the foundational work of the astrophysicist Michael S. Turner. This is the model that says the universe is defined by the Big Bang, dark matter, and dark energy.
And then, in the red corner, we have the challenger, the water matrix framework, proposed by G. Ramsey Holmes.
Right, which is this radical theory claiming that space-time isn't just an abstract geometry, but an actual physical lattice of water molecules.
A literal physical medium.
Exactly. And the rules of engagement today are simple. We are going to be completely neutral referees. No opinions from us. We're just pulling the references as requested.
We are going to analyze the specific experimental references, the Hugh et al. Paper, the Sear paper, the observational data to see which framework actually survives scrutiny.
So to our friend at CERN, put down the wrench or the calibrator or whatever you're holding and put on your headphones. It is time to rumble.
Let's start with the champion, the incumbent, Lambda-CDM. Because if you open any textbook in any university anywhere in the world today, this is the model you are going to see.
Right. But to understand why it's the champion, why it won in the first place, we have to look at the inventory of the universe.
And we are leaning heavily on Michael S. Turner's work here, specifically his defining papers from the late 90s and early 2000s.
Papers like Dark Matter and Dark Energy in the Universe. Turner really frames this whole thing as an accounting problem, doesn't he?
He does. It's like he's auditing the universe's books. He lays out what he explicitly calls a plausible, complete accounting of matter and energy.
And we really have to remember how revolutionary that accounting was at the time.
Oh, absolutely. Because before this, cosmologists were mostly talking about standard CDM.
Which was just cold dark matter, no dark energy.
Right, cold dark matter only.
Yeah.
So the shift from standard CDM to Lambda-CDM was a massive paradigm shift in physics.
And the lambda there, just to clarify, is the Greek letter that represents the cosmological constant, dark energy.
Exactly. But before we get to the invisible stuff, the stuff that drives our technician friend crazy, let's talk about the visible stuff. Let's talk about us.
The stuff we can actually touch and interact with.
Precisely. Turner breaks down this cosmic pie chart, and it's a really strange pie. He points out that baryons, which is normal matter.
Protons, neutrons, electrons.
Right. Stars, gas, dust, you, me, the microphone in front of us, the CERN technician's coffee cup. All of that normal matter makes up roughly 5% of the critical density of the universe.
5%. That is just, it's humblingly small.
It really puts our entire existence into perspective.
It does. We naturally tend to think that matter, stuff we are made of, is the main event of the universe. But cosmologically speaking, we are basically just a rounding error.
And it gets even smaller if you look closer. Of that 5%, the vast majority is just intergalactic gas, the actual stars and planets. That's a fraction of a percent.
Wow. Okay, so what else is on Turner's inventory list?
Well, you have neutrinos, these ghost particles just constantly streaming through everything. Turner puts them somewhere between maybe 0.3% and 15% of the total, but most likely on the very, very low end of that scale.
Okay, so we've got the visible stuff at 5% and a tiny sprinkle of ghost particles. Then we hit the heavy hitter.
Right. Cold dark matter. This is the invisible mass that actually holds galaxies together.
Because without it, based on how fast galaxies spin, they would just fly apart, right?
Exactly.
Yeah.
Based on galactic rotation speeds and the dynamics of galaxy clusters, Turner puts cold dark matter at roughly 30% of the universe.
Okay, so let's do the math on that. 5% baryons, 30% dark matter. We are at 35% total. Where's the other 65% of the universe?
That missing chunk is the lambda. It's dark energy, or vacuum energy. Roughly 65% of our entire universe is this mysterious force that is just pushing everything apart.
Now, this is exactly where a skeptical listener, and definitely our CERN technician, might stop us and say, hold on, why?
Why do we accept this?
Yeah. Why do we accept a foundational model where 95% of the universe is made of invisible stuff that we can't touch, can't see, and don't fully understand? Why is this model considered the absolute winner?
And why isn't it considered a massive failure of physics? That is the crucial question, and Turner answers it beautifully in his papers. We accept it because it solves problems that were literally breaking cosmology.
Breaking it how?
There was a major crisis, and I mean a fundamental physics is fundamentally broken level crisis regarding the age of the universe.
The age crisis. I love a good crisis in science. It usually means we are right on the edge of learning something huge. Unpack the age crisis for us. What was the actual conflict in the data?
It's a really simple timeline problem, honestly.
Hmm.
Before Lambda-CDM, if you calculated the age of the universe using just matter, just the gravity of stuff pulling on other stuff, and you looked at the expansion rate, the Hubble constant,
Right.
that math suggested the universe was only about 11 billion years old.
Okay, 11 billion years. I mean, that sounds like a long time to an average person.
Sure, it does. Until you look at the actual residents living inside the universe, specifically globular clusters.
Which are what, exactly?
They're these incredibly dense spherical balls of ancient stars that orbit the outer halo of the Milky Way. Now, astrophysicists have very, very good, rigorous models for how stars bring fuel and how they age.
Stellar evolution models.
Exactly. And when they use those models to date the stars inside these globular clusters, the ages came out to be anywhere between 13 and 17 billion years old.
Oops. Yeah, that is a massive glaring problem. You have stars that are 15 billion years old,
Yeah.
sitting inside a universe that is only 11 billion years old.
Exactly. It's a fatal conceptual flaw.
Yeah.
You cannot be older than your mother. You cannot be older than the literal house you live in. This paradox was threatening to entirely dismantle the Big Bang model.
And Turner explains that this is exactly where Lambda comes riding to the rescue.
Enter the cosmological constant.
Right. So how does adding dark energy fix the timeline?
By adding lambda, you change the entire mathematical history of the universe's expansion. Instead of the universe just constantly slowing down over time because gravity is pulling everything inward.
Which is what everyone assumed was happening.
Right, but with lambda, the universe eventually starts accelerating outward. This change in the expansion rate effectively stretches out the timeline of the universe.
It gives the universe more time to have existed.
Exactly. It allows the universe to be older, up to maybe 16 billion years old, which comfortably fits those ancient stars. It resolves the paradox.
So Lambda acts like a cosmic youth serum, or I guess the opposite. It's an anti-aging cream that allows the universe to admit its real older age.
It balances the cosmic checkbook. But the age crisis isn't the only thing it fixed. Turner also heavily emphasizes the cluster baryon fraction.
The cluster baryon fraction, that sounds incredibly technical, but it's actually a very visual concept, right?
It is. Let's break it down, because this is the kind of rigorous, observational detail our CERN friend is asking for. Imagine you are looking at a massive cluster of galaxies through a telescope.
Okay, got it.
You have hundreds, maybe thousands of galaxies swarming around each other. And floating in the space between all those galaxies, there is hot gas.
Very hot gas.
Incredibly hot. So hot that it glows brightly in X-ray wavelengths. Now, If you measure the total mass of that glowing gas, which are the baryons, normal matter, and you compare it to the total mass of the entire cluster.
And you get the total mass by looking at how fast those galaxies are whipping around using gravity.
Right, exactly. So you compare the gas mass to the total gravity mass, and you get a ratio.
And what exactly does that specific ratio tell cosmologists?
It tells us that baryons make up roughly 15 to 20% of the total matter in that cluster. Now, if you extrapolate that ratio out to the entire universe, it mathematically implies that the total amount of matter, omega matter, is only about 0.3.
Meaning, matter only accounts for roughly 30% of what is needed to make the universe flat.
Yes.
And we should pause here because when we say flat in cosmology, just to be super clear for everyone listening, we are definitely not talking about a flat Earth or a flat piece of paper.
No, no. We were talking about cosmic geometry. We mean that Euclidean geometry applies on the largest cosmic scales, meaning parallel lines will always stay parallel, and the angles of a triangle will always add up to exactly 180 degrees, no matter how big the triangle is.
And standard inflation theory, the theory that brilliantly explains the super early universe, demands that the universe must be geometrically flat, meaning omega total has to equal exactly 1.0.
And there is the gaping hole in the budget. Inflation says the total must be 1, but the matter in the galaxy clusters only adds up to 0.3. You're missing 0.7.
So you just plug the hole?
Precisely. That 0.7 is lambda, dark energy. 0.3 matter plus 0.7 lambda equals exactly 1.0. A perfectly flat universe.
It makes the hard observations of galaxy clusters completely compatible with the foundational theory of the Big Bang. It just fits the data perfectly.
It fits perfectly. And Turner also talks about what he calls smoking gun predictions. He specifically points to the deceleration parameter, known as Q0.
Q0, I remember seeing this highlighted in the source papers. It feels like the ultimate, undeniable test of the model.
This is truly the test that solidified Lambda-CDM's massive lead in physics.
Right?
Think about just throwing a baseball straight up into the air.
Okay, gravity starts pulling it back down immediately.
Right, so as the ball goes up, its speed slows down, it decelerates. In a universe filled with just matter, gravity should constantly be slowing the cosmic expansion down.
The bang happened. Everything flew violently apart, and now the combined gravity of all this stuff is desperately trying to pull it all back together.
Exactly. And in that scenario, the mathematical value for Q0 should be a positive number, somewhere around positive 0.5.
But Lambda-CDM makes a very weird, counterintuitive prediction.
It does. It predicts that because of the repulsive force of dark energy, the expansion isn't actually slowing down at all. It's speeding up. It's accelerating.
So it predicts that Q0 shouldn't be positive, it should be a negative number.
Specifically around negative 0.5.
And then when astronomers actually looked at Type I supernovae in the late 90s...
Those are the exploding stars that act like perfect standard light bulbs for measuring distance.
Right. When they measured them, what did they find?
They found undeniable acceleration. The expansion of the universe is actively speeding up. Lambda-CDM confidently predicted it, and the supernova data completely confirmed it.
As Turner puts it in his paper, Lambda-CDM is currently the only model that is consistent with all the major data sets simultaneously. The cosmic microwave background anisotropy, the large-scale redshift surveys, and the supernova data.
It sweeps the board.
So in the blue corner, we have a model that just objectively works. It fits the observations. It solved the age crisis. It solved the cosmic flatness problem.
And it is very big but.
Yes, but it relies entirely on two massive invisible components, dark matter and dark energy. We have never seen them in a lab. We don't actually know what they are. We just know we desperately need them to make the math work.
And that specific but is exactly what Ramsey Holmes and the proponents of the water matrix theory latch onto. Which finally brings us to the red corner, the challenger.
Ramsey Holmes steps into the ring.
Holmes essentially says, look, stop looking for invisible magic particles. Stop inventing cosmic ghosts just to fix your broken equations. Look at the medium itself.
Look at the water matrix. Let's clearly state the core postulate here, exactly as Holmes writes it in the source material. He states, space-time is not an abstract geometric manifold, but a physical medium composed of water.
Now, I know that sounds completely absurd at first glance, and I really want to pause here because for our CERN technician listening, this probably sounds like absolute unhinged pseudoscience. Space is water, give me a break.
Yeah, it sounds like ancient mythology.
It does. But we promised a rigorous duel. We're here to look strictly at the physics and the math, not the wild headline. Holmes makes a very subtle philosophical argument here. He says that Einstein brilliantly described what spacetime does. It curves and bends, but Einstein never actually said what spacetime is.
That is a fascinating distinction. General relativity is essentially a mathematical description of behavior, not a definition of an actual substance.
Exactly. Holmes claims he has finally identified the physical substrate. He argues that the vacuum of space is not a vast, empty nothingness. It is a plenum, a physical fullness.
And that substrate, that fullness, is a lattice.
Yes, a continuous structural lattice of water molecules. But he's not talking about liquid water just sloshing around out there like a giant swimming pool. He describes a very specific rigid structure based on what he calls the asymmetric hydrogen bond.
This is the strong-weak rule we saw repeated in the notes.
Right. Holmes cites detailed chemical research, including work by Hunger et al., showing that water molecules naturally form bonds where one hydrogen bond is uniquely strong and the adjacent one is weak.
So it creates a repeating pattern. Strong, weak, strong, weak.
Exactly. And that alternating pattern propagates outward, forming a highly structured lattice.
So it's essentially a cosmic grid.
A grid, yes. And the critical property of this grid is that it is fundamentally scale invariant.
What does scale invariant mean in this context?
Holmes argues this physical lattice extends seamlessly from the water, sitting in the glass on your desk, right up through the atmosphere, out into the cold interstellar clouds, and stretches all the way to a massive cosmic shell at the very edge of the observable universe.
But wait, space is empty. I mean, we know this for a fact. We shoot satellites through it every day. There's no drag.
Holmes doesn't deny the emptiness we perceive. He argues the density of the lattice simply changes drastically. In a glass of water, it's incredibly dense. Out in deep space, it gets stretched incredibly thin. We're talking less than one single molecule per cubic centimeter.
But his point is that the geometric character of it, the actual lattice connection, never breaks. It is one continuous web across the cosmos.
That's the claim. He even writes out an incredibly bold equation for space-time itself. He writes, frequency plus H2O plus gravity equals space-time.
He's saying those elements are physically inseparable.
You cannot have gravity without the lattice medium. You cannot have the geometry of space without the water molecules to define it. And to support this radical idea, he points heavily to the absolute universality of water as his primary evidence.
This was actually a really surprising point in the source material for me. We usually think of water as something incredibly special to Earth, you know, the rare blue marble oasis.
The astrophysical papers completely contradict that idea. Water is everywhere.
Give us an example from the references.
Holmes directly cites massive detections of water vapor surrounding quasars at a redshift of 3.91.
Which means how far away?
That is roughly 12 billion light years away from us, at the very dawn of the universe. And they didn't just find a little bit. They detected 140 trillion Earth masses of water vapor swirling around a supermassive black hole.
140 trillion times the water on Earth. That is an incomprehensible amount of bathwater.
It really is. He argues that water has been positively detected in literally every single astrophysical environment we have ever looked at with sufficient sensitivity. From the moons in our own solar system to the incredibly violent accretion disks of the earliest known galaxies.
So his fundamental argument is basically, where water is absent, gravity is absent. And where water is present, gravity is present.
It is a massive correlation argument. If space-time is quite literally the water lattice, then obviously the lattice material must exist everywhere we see gravity working. He completely flips the standard script.
Because usually we say, oh, look, water's pooled there because a planet's gravity pulled it in.
Right, and Holmes says, no, the gravity only exists there because the density of the water lattice is allowing it to manifest.
Okay, but look, saying space is water is great poetry, but we need actual mechanics. Our CERN technician is probably rolling their eyes into the back of their head right now saying, show me the physical forces. Einstein says gravity is pure geometry. Mass physically bends the four-dimensional manifold of space and time. What exactly does Holmes say gravity is?
Holmes says gravity is simply refractive index.
Refractive index. But that's optics. That is literally how eyeglasses and camera lenses work.
It works exactly like a lens. Think about putting a straight plastic straw into a glass of water. It suddenly looks bent or broken, right?
Right, because light slows down when it hits the water.
Exactly. Light slows down when it enters the denser physical medium of the water. That change in speed causes the light path to change direction. That is classical refraction.
So how on earth does that optical concept apply to gravity and black holes?
Holmes argues that physical mass, like a giant star or a dense black hole, puts physical strain on the surrounding water lattice. Yes. Imagine a heavy bowling ball sitting on a trampoline net. It stretches and pulls the net tight around it. Holmes says mass essentially compresses the cosmic water lattice, locally increasing its optical density.
And that compression mathematically changes the speed of light in that specific region.
It perfectly changes the refractive index, which physicists denote as n of r. Holmes actually takes this concept and derives the exact Schwarzschild metric, which is the absolute gold standard mathematical equation for describing gravity around a black hole, and he derives it using nothing but refractive index optics.
Walk us through that derivation, seriously, step by step, because this is exactly where the rubber meets the road. If the math actually matches general relativity, we have to stop and listen.
Okay, he starts with a base formula for calculating the refractive index near a massive object. The formula he uses is n of r equals 1 minus 2 gm over c squared r, all raised to the negative 1/2 power.
Now, for anyone who is familiar with standard relativity, that specific term, the 1 minus 2 gm over c squared r, that is everywhere in Einstein's math, that is the literal Schwarzschild factor.
It is completely identical. Holmes rigorously argues that if you simply assume that mass physically strains a lattice and that light has to travel through that strained, denser lattice, you naturally get the exact same curved path for the light that general relativity predicts using curved nothingness.
So he boldly claims he can mathematically recover all the classic tests of relativity.
Yes, all of them. Let's take gravitational time dilation. In standard GR, we say time physically slows down near a black hole because the abstract geometry of time itself curves.
And Holmes says,
Holmes says no, time simply appears to slow down because your clock is operating inside a thicker optical medium. All physical processes naturally move slower inside a highly dense lattice.
what about gravitational redshift? You know, the effect where light actively loses energy and shifts red as it struggles to climb out of a deep gravity well.
Holmes treats that purely optically. He says it's simply a light wave moving from a high-density refractive medium deep in the well out to a low-density medium in deep space. The wave naturally stretches out. Same exact mathematical result.
Now, here's the really big one, light deflection. During the famous 1919 solar eclipse, Arthur Eddington proved Einstein was right because he photographed starlight bending around the mass of the sun.
Right, this was the exact moment Einstein became a global celebrity.
And this is always a very tricky point in physics history. Because in standard Newtonian physics, if you just calculate the bending of a light particle acting like a bullet passing a massive object, you do get a bend. You get 0.87 arc seconds of bending.
But Einstein predicted double that amount. He predicted 1.75 arc seconds.
Because in relativity, space curves and time also curves, that creates the missing factor of 2.
And Holmes addresses this missing factor incredibly specifically. He says that because his physical lattice actively affects both the time component, dt, and the spatial component, drr, because it's a real physical medium with real density, you naturally recover the full mathematical factor. He claims his refractive optics approach matches the precise 1.75 arc seconds of deflection perfectly.
What about the perihelion precession of Mercury? That weird shifting wobble in Mercury's orbit that Newton's laws simply couldn't explain, but Einstein solved perfectly.
43 arc seconds per century of wobble. Holmes says this purely comes from a velocity-dependent interaction with the medium. As Mercury moves faster and slower as it orbits through the denser lattice near the Sun, the physical drag, or the refractive coupling, changes dynamically. He derives the exact same 43 arc seconds.
Okay, this is the ultimate CERN tech check moment. The mathematical result of the water matrix is identical to general relativity.
Numerically, on paper, yes. It produces the exact same numbers. But the underlying physical mechanism is completely different. Einstein tells us that the abstract geometry of absolute nothingness is curving. Holmes tells us that the optical density of an actual physical somethingness is changing.
So we're sitting here with two vastly different models that give us the exact same numerical answers for the solar system. That makes it incredibly hard to choose a winner. But let's be honest, anyone can write a reverse-engineered formula that perfectly matches known data after the fact. That is just called curve fitting.
Right.
The technician demanded references. They want the hard experimental evidence that supports the water theory specifically. Not just evidence that says it matches Einstein's math, but evidence that screams, here is why the medium absolutely must be water.
Let's open the references file then. because this is where we get deep into the experimental fluid dynamics.
Let's look at Exhibit A. This is the highly specific paper by Hugh et al., published in 2013.
The title of the paper alone is wild. It's called Negative Effective Gravity in Water.
That immediately sounds like bad sci-fi, negative gravity.
I know, but it is real, peer-reviewed fluid dynamics. Hu and his team literally built a physical water channel in a lab. And at the bottom of this channel, they precisely placed what are called Helmholtz resonators.
Which are essentially just tubes with a slit cut in them, right?
Basically, it's the exact same acoustic principle as blowing air over the top of a glass beer bottle to make a tone.
Okay, so they have these resonating tubes underwater. Then what?
They systematically sent water waves rolling over these tubes. And they documented something genuinely incredible. When they hit a very specific wave frequency, exactly 4.4 hertz, the effective gravitational acceleration, denoted as GF, suddenly dropped.
Dropped by how much? Like a fraction of a percent?
It didn't just drop slightly, it completely crossed the zero line and went negative.
Meaning the water literally pushed back against gravity. The waves started behaving as if they were falling up.
The wave dynamics behaved entirely as if local gravity was reversed. The physical lattice, in this specific case, the structured water inside the channel, actively rejected that specific 4.4 hertz frequency. Holmes fiercely argues this is a critical, undeniable clue. He says it proves that gravity interacting with water is not just a dumb, fixed constant. It is fundamentally frequency-dependent.
So if you can perfectly tune the vibrational frequency of an object, you could theoretically turn its gravity off.
Or entirely reverse it. Holmes connects this directly back to his core lattice theory. Gravity isn't just an inherent isolated property of a mass. It is a dynamic, resonant coupling between the frequency of an object and the specific medium it's sitting in. If you hit the exact resonant frequency of the water lattice, you break the gravitational coupling.
I mean, that is a massive conceptual leap to go from a tiny water tank in a lab to the gravity of a star, but it undeniably establishes that water has some very weird frequency-dependent gravitational properties.
It does.
So let's look at Exhibit B, the analog gravity experiments.
This is the detailed work of Weinfurtner in 2011 and Torres in 2017. Now, we have to be completely fair to these original researchers. They were definitely not trying to prove the water matrix theory. They were conducting what standard physics calls analog gravity research.
Explain that concept for us. Why do highly credentialed physicists spend time simulating gravity in a tank of water?
Because black holes are notoriously hard to visit in person. We can't put sensors inside them. So physicists use physical water flumes to safely simulate the complex math of curved spacetime. They create highly controlled fluids flows where the water actively moves faster than the speed of the waves trying to travel through it.
And that speed difference creates a mathematical boundary.
Exactly. It creates a physical horizon. The waves physically cannot swim upstream past that specific point no matter what. It perfectly mimics the mathematics of a black hole's event horizon.
And what specifically did they find when they created these water horizons?
They directly observed exotic phenomena like rotational superradiance. They were actually able to extract measurable energy out of a spinning water vortex, which behaves exactly like the famous Penrose process, which predicts you can steal rotational energy away from a spinning black hole.
Now, standard textbook physics looks at this and says, what an incredibly cool analogy. The fluid math just happens to look identically like the space-time math.
But Holmes aggressively pushes back on that. He says, it is not an analogy, it is diagnostic. He argues that water waves perfectly satisfy the Klein-Gordon equation, which is the fundamental equation for quantum fields operating in curved spacetime, purely because spacetime literally is water.
Oh, I see. He says the reason water simulates gravity so flawlessly is simply that gravity is fundamentally a water-based phenomenon.
It is a radically bold reinterpretation of the data. It's essentially saying it walks perfectly like a duck, it quacks perfectly like a duck, therefore the universe is in fact a giant duck.
He's saying we are actively staring at the literal mechanism of gravity right there in the lab flume, but we are too blinded by the word analogy to realize what we found.
Exactly his point.
Okay, let's move on to Exhibit C, the tidal dissipation ratio. Now, this one feels a lot more tangible to me. This isn't abstract math. This is about the Earth and the Moon.
Yes, this is a very hard data point from standard geophysics. We look at exactly how the Earth physically dissipates the immense energy coming from the Moon's tidal pull. The Moon's gravity constantly pulls and squeezes the Earth, which creates massive internal friction.
And that friction naturally generates heat.
Right. Now, Earth's fluid oceans dissipate about 3.5 terawatts of energy. That accounts for roughly 95% of the total tidal energy being absorbed.
And what about the solid Earth? The continents, the mantle, the rock?
The entire solid mass of the Earth dissipates only 0.2 terawatts. That creates a massive 17-to-1 ratio between the water and the rock.
Okay, but why does that specific ratio matter so much? Rock is incredibly stiff. Water is obviously a fluid. Isn't it just painfully obvious that water would naturally slosh around more, create more friction, and therefore burn off more energy?
That is exactly the standard textbook answer. Simple, fluid friction. But Holmes asks a much deeper question. Why is water so vastly, disproportionately better at grabbing hold of gravitational energy than dense rock is? He argues that mere fluid sloshing isn't mathematically enough to explain that extreme level of efficiency.
He thinks there has to be something else actively coupling the water to the gravity.
He fundamentally argues that the structured water lattice physically couples to the gravitational forcing 17 times more efficiently, simply because the water lattice actually is the primary conductor of gravity. He views the water as the literal wire that carries the gravitational signal. The rock is basically just a poor insulator.
So the rock of the Earth is mostly just passively dragging along for the ride, but the water on the surface is the active, engaged participant in the gravitational exchange.
That is his exact interpretation of the geophysics. He believes this extreme energy efficiency is a clear, measurable signature of the lattice structure directly connecting the mass of the Earth to the mass of the Moon.
Okay, we have one more exhibit to get through. Exhibit D, the active responder study by Zickery, Koropkin, and Cooker.
This is a deep dive into high-level fluid dynamics regarding raw impact forces. They rigorously analyzed what physically happens when a solid object violently enters water. Now, standard physics almost always treats the water as just passive inertia.
Meaning it's just dead weight that the object has to forcefully push out of its way to keep moving.
Right. You hit the water is forced to move. It's totally passive. But Zickery's team uncovered a mathematical term showing that gravity literally changes the water into what they define as an active responder.
Active responder. I mean, it almost makes it sound like the water is actively fighting back against the object.
In a mathematical sense, it is. They discovered a specific gravitational correction to the impact force that actively grows stronger over time. Specifically, it grows at a rate of 10 to the power of 3/2. The longer the physical interaction lasts, the more the water dynamically reorganizes itself to push back and transmit force.
And how does Holmes use this?
Holmes interprets this 10 to the 3/2 growth as the medium essentially waking up and actively dynamically coupling to the falling object. It shows gravity isn't just mass reacting to mass. It's a complex, time-dependent response mechanism of the water medium itself.
Okay, so let's summarize the Challenger's evidence so far. We have these highly specific experimental nuggets. Negative gravity recorded at 4.4 hertz, a massive 17-to-1 tidal dissipation ratio, the water acting as a T to the 3/2 active responder. It definitely builds a very intriguing circumstantial case that water is weirdly fundamentally tuned to gravitational forces.
It does.
But now we have to turn and address the absolute elephant in the room. We have to talk about the dark sector.
This is where the heavy lifting really happens in this duel. Lambda-CDM is the undisputed champion, precisely because it cleanly provides mathematical explanations for dark matter and dark energy. The water matrix absolutely has to explain those phenomena away without using any invisible particles. If it can't do that, it instantly loses the duel. Let's start with dark matter. We look up and we see galaxies spinning way too fast. If it was just the gravity of the visible stars holding them together, they would literally just fly apart into deep space. Lambda-CDM confidently says there are massive invisible halos of WIMPs weakly interacting massive particles or axions holding them together. We can't see them, but their invisible gravity perfectly keeps the stars locked in. And Holmes firmly says, no WIMPs, no axions, no ghost particles. He looks purely at the mechanics on the galactic scale.
He brings it back to that concept of strain again, doesn't he?
Yes, heavily. A spinning galaxy is a phenomenally massive, incredibly energetic object. Holmes argues that this colossal rotation creates a massive torsion or tension deep inside the cosmic water lattice. Imagine holding a wet towel and twisting it violently. It gets much tighter.
It gets physically stiffer and more dense.
Right. Holmes argues this massive galactic twist drastically modifies the refractive index locally around the galaxy. It naturally creates a giant optical lens of much denser spacetime simply for the mechanical rotation alone.
So the highly twisted dense water lattice naturally acts exactly like extra gravity.
Exactly. The extra gravity that is desperately needed to hold the outer stars inside the galaxy isn't emanating from invisible chunks of mass. It's coming entirely from the physical stiffness of space itself, the lattice fiercely resisting the galactic twist. He mathematically claims this perfectly recovers the observed galactic rotation curves without needing to invent a single microscopic particle of dark matter.
That is incredibly elegant. If it's mathematically true, it completely removes the messy need for a ghost particle. But what about the bigger problem? What about dark energy? The entire universe is accelerating apart. Lambda-CDM proudly says it's vacuum energy, the cosmological constant. What exactly does the water matrix say is pushing the universe apart?
Okay, this is undeniably the wildest, most radical part of the entire theory. And I really need our CERN technician to bear with us here for a minute because this gets extremely trippy. Holmes fully introduces the concept of the cosmic shell.
A giant cosmic bubble.
He formally calls it a gravitationally vacuum condensate shell.
Hmm.
He argues that the entire universe is actually a finite cavity, physically bounded by a genuinely giant water matrix shell.
Wait. So the universe literally has a hard edge.
In his specific model, yes, it does. And he argues that cosmic acceleration isn't caused by some mysterious, invisible dark fluid aggressively pushing galaxies apart from the inside. He says the acceleration is simply surface tension.
Surface tension, just like a literal soap bubble naturally wanting to expand outward.
It's exactly like a bubble. The physical surface tension of the cosmic shell constantly pulls outward on itself to systematically minimize its own curvature energy. Furthermore, Holmes mathematically treats the entire universe as a giant resonant cavity. He says this outer shell perfectly reflects specific internal frequencies back inward. And this is exactly where a very specific number from the source notes comes into play, 350 nanometers.
I saw this number highlighted in the notes, and I honestly didn't know what to make of it. He lists a frequency of 8.56 times 10 to the 14th hertz.
That highly specific number is the exact frequency that mathematically corresponds to water's sp3 hybridization energy. It is a fundamental chemical bond energy. It is literally the exact amount of energy required to actually forge the hydrogen bond lattice in the first place.
Okay, so the edge of the universe is chemically tied to water bonds.
Holmes aggressively claims that the cosmic lattice becomes mathematically zero reflective at this precise frequency, meaning it absorbs that specific frequency perfectly without any bounce back. This total absorption creates a hard holographic boundary at the edge of space.
So you are telling me the literal edge of the entire universe is perfectly tuned to the chemical vibration of a standard water molecule?
That is his exact published claim. He argues that this specific outer boundary condition naturally drives the massive resonant cavity modes inside the universe, and we simply misinterpret those expanding cavity modes as dark energy. No invisible dark energy fluid is required at all. It's just the macro mechanics of a vibrating water bubble.
It is a total absolute unification of scale. He is desperately trying to wrap every single cosmic phenomenon into one single physical substance.
One single physical medium, which is water, and one single variable, which is frequency.
Let's actively break down that unification of forces, because our friend at CERN, they deal with the chaotic standard model of particle physics every single day. They have to juggle gluons, W and Z, bosons, photons, gravitons. It's a complete zoo of particles.
It is a zoo, and Holmes essentially says, close the particle zoo down. There is only one animal in the cages, the lattice. He says the four fundamental forces of nature are really just different pitches, just different resonant notes being played on the exact same guitar string.
Walk us through those pitches. How do you possibly get the strong nuclear force out of a water lattice?
Let's start with the strong force. He defines that as ultra-high frequency coupling. At the tiny scales of an atomic nucleus, the water lattice nodes are packed incredibly tightly together. Very high pitch, incredibly strong physical bond. This intense, high-frequency, localized vibration is what physically holds the atomic nucleus together.
And what about the weak nuclear force? The force responsible for radioactive decay?
He classifies the weak force as a transformative frequency. It's a specific resonant vibration that temporarily allows state changes to occur, like beta decay. It's basically a localized vibration that gets just strong enough to suddenly flip the physical state of a lattice node.
Okay, what about electromagnetism? Light? Magnets, electricity?
Electromagnetism is purely the propagation of a frequency wave through the lattice structure itself. A photon of light is literally just a vibration traveling through the water matrix, just like the sound wave is just a physical vibration traveling through the air in this room.
And then finally, gravity.
Gravity is the macro bulk coupling. It's the ultra-low-frequency structural response of the entire lattice structure as a whole. It's the large-scale groaning or bending of the massive lattice under extreme weight.
So if I have this right, sound physically travels through water, light physically travels through water, meaning space, and gravity is just the vast ocean of water physically stretching and straining.
Precisely. He directly compares it to the difference between sound and light. Sound waves naturally travel much faster in water than they do in the air. Light waves naturally travel much slower in water than they do in a pure vacuum. He mathematically argues these are all just different medium responses. There is absolutely no need for a magical, invisible graviton particle.
It is a breathtakingly beautiful conceptual picture. I fully admit there's a massive aesthetic appeal to it, the idea that the universe is fundamentally one thing. But, as our CERN technician deeply knows, philosophical beauty doesn't win Nobel Prizes.
It definitely doesn't.
Predictions do, rigorous falsifiability does. You can have the most mathematically pretty theory in the world, but if it doesn't predict something entirely new that we can actually measure in a lab or telescope, that's totally useless to physics.
And this brings us to the ultimate crux of the duel. Turner's Lambda-CDM model made incredibly bold predictions decades ago. It accurately predicted the precise temperature peaks in the cosmic microwave background. It accurately predicted the complex age of the universe. It accurately predicted the shocking cosmic acceleration, the negative Q0, and it brilliantly passed every single one of those tests.
But it still fundamentally leaves us with 95% absolute ignorance about what the universe is actually made of. We have an incredibly accurate map that perfectly guides us, but the map's legend just says, "Here be dragons," for nearly the entire cosmos.
That is undeniably true. So the question is, does Holmes offer highly specific, testable predictions? Or is this entire water matrix thing just clever mathematical storytelling?
He actually offers a very rigid checklist specifically for experimentalists like our technician. Let's go through the definitive water matrix predictions. If our listener violently wants to kill this theory once and for all, here is exactly how they do it.
Okay, prediction number 1, anomalous light deflection. We talked earlier about how he perfectly recovers the standard Einstein bending of starlight, but he explicitly states it's not exactly identical.
How is it mathematically different?
The physical nature of the lattice introduces a very tiny residual optical effect. He predicts exactly about 2 micro-arcseconds of extra anomalous bending beyond what general relativity allows for.
2 micro-arcseconds. That is unfathomably tiny. Do we even have the technology to measure something that small?
We are getting incredibly close. The specific instrument designed for this is called gravity plus a jar.